You don't need your textbook. I don't know what I was doing there, but you do need a calculator, pencil, and paper for today's class. So if you have that, that would be great. I'll turn on the mic and do my audio setup wizard here, and I'll be right back on, you guys. All right, I know some people are probably still going to sign on, but we'll get started and try and figure out today's poser of a problem. So I don't know if you noticed, but last day I had the pictures of the snow and the snowshoes, and then reality hit, so I just put some pictures of rain and a flood. I feel like the backfield's going to look like this pretty soon. I don't know. I wish it would stop raining. Anyway, here we are, and this won't be a long class tonight. We're learning about the area of a triangle. And I know that we were talking about area of a rectangle last time. Now, the idea behind all of your sort of geometry formulas is that they will work no matter what. So how many people remember last year the total number of degrees that you find of the angles in a triangle? Can anybody remember that? The number of degrees in a triangle is always the same. Seeing a lot of stunned silence out there. Maybe someone knows. Let's look. 110. 180. So if you add up the 3 degrees in a triangle, and I'm going to get my pointer here because I just realized you guys don't always see what I'm seeing. So if I'm looking at this triangle here, it has 3 identical angles. It's called an equilateral triangle. How much is each one of those degrees going to be? You can put your hand down, Lexi. How many degrees is each one of those going to be? Has to add up to 180. And if they're all exactly the same, it would be 60. So one of my little challenges to you guys that like to have a little bit of a challenge is try to construct a triangle, a true triangle, where so it's 3 sides. So you can see there's the different kinds. There's right angle, equilateral, isosceles, scalene. I want you to try and construct me a triangle that does not come out to 180 degrees. All right? So every one of these triangles that we're seeing here, this one is one, here's another one. One thing we know about them is a triangle is like half of a rectangle. Now I'm going to try and show you this. I don't know if I'm going to be able to. Oh no, figures I went somewhere else completely. I don't know. Am I back? Okay, I'm back. I'll draw a rectangle on the page just as I can do. Okay, so let's see what happens. I wish it would let me. Okay, here we go. Oh, look at that. Now, here's a nice rectangle I've drawn on the page, and you can see that is, and we would know that what we would do to construct that is 4 parallel angles, or 4 parallel lines. And what do you think I'm going to do to calculate the area of this rectangle? Who can tell me that from today's class? You can tell me from today's class how I get the area of a parallelogram which includes a rectangle. Length times width, says Manry, and she's right. Remember that we can always, that's right. Height times base, says Stephen, and he's right as well. So last year we learned length times width because we only learned the area of, oh, that's a nice square. We only learned the area of squares and triangles last year. But this year, we're learning for parallelograms as well. So there you can see that this forms a square here, so it's easy to do base times height. And base times height will give you the area there. So base times height. That's just terrible. All right, so now that we've figured that out, I'm going to clear the page. I'm going to redraw my triangle. And I'm going to ask you to think about something. I don't want you to blurt out. I want you to think for a minute. If it's the case that my rectangle is base times height, and you can see that a rectangle can be split to make what? 2 triangles. Thank you. Let's see what people are saying. The rectangle split in half becomes 2 triangles. So, if the area of a rectangle is base times height, how do you think we calculate the area of a triangle? So if I wanted to get the area of this or of this, what would I have to do? Well, I'm thinking. I might type something. Let's see what happens. If I'm trying to figure out the area of this or this piece, what could I do? Okay, is it 2 times? I need to think about that for a minute. Base, I don't know if you can see me moving this guy around. There's my base. There's my height. Not times the degrees, you're getting closer, guys. How about if it was this? Look at what I wrote there. Or base times height divided by 2. If, follow my logic, if here I've got my rectangle, and we know that that's base times height. If I split it and it becomes 2 triangles, that is half the area of my rectangle. So I should be able to do base times height and divide it by 2. Anybody want to talk to me about that or tell me about that or agree or disagree? Make sense? So base times height would give us the area of the entire rectangle. And if we split that in half and make 2 triangles, each one of those is going to be base times height divided by 2. And that is actually the formula that you have to remember for calculating the area of a triangle. So to calculate the area, you multiply the base and the height, and you split it in half. Now the height is always measured by using a 90-degree angle, and this is a right angle triangle. So that one's really easy to find a 90-degree angle. So what you're going to measure here, you're going to measure height all the way. Can you see my hand moving? And then you're going to measure base. All right. So this one is relatively easy. All right. A 90-degree angle, no problem. So a right angle triangle, easy. Some of the other ones, not so easy. So let's take a look. I'm going to go over the page. Did I do that? Where do I find my 90-degree angle for this one to measure the height? And we always measure the height from the base. So where am I going to go? I actually left a pen there. Manreet says in the middle. Why, Manreet? Don't you get to use your microphone ever? I feel like I'm just talking ahead here. No, Manreet's not going to use one. Okay, I'm going to get my straight angle. So this is what Manreet said to do to get my 90-degree angle. I'm going to do this as well as I can. Oh, figures. Not that one. I'm going to clear that off. I'm going to try it again. You think I'd get better at this. All right, let's try again. So what I'm trying to do, basically, go top to bottom and create a straight angle. Now, I can create a 90-degree angle there because you can watch here. I'm going to draw over to there. Close enough. Almost caught it. That's a 90-degree angle. So what I'm going to do then is I'm going to multiply my base times my height. And I want you to understand what's behind that. All right? I want you to understand what's behind that. So the height, it's not going to let me write. Okay. Go back to my, I'm going to go back to using my mouse because it's not cooperating well. All right. So I'm going to do base times height. And I'm going to divide by 2. And we're going to remember that our height is always measured from a line that makes a 90-degree angle from the bottom to the top. Okay? And in the middle there. All right. So let's do some triangular calculations. And we're probably not going to have a long class today, which is great. So the very first one has a base of 5 and a height of 4. So what is the area going to be? Be careful. Be careful. It's going to be in centimeters squared for sure. Let's remember what our formula is. Base times height divided by 2. All right. So Stephen's right there, 10 centimeters squared. We multiplied base times height, which was 5 times 4. And we divided that all by 2. So that equals, it's kind of like handwritten numbers, 20 divided by 2. And that equals 10. All right? So let's try and figure out the next one. We'll clear off the page. Let's see if we can figure it out. So the next one is 3 centimeters along the base, 8.5 for the height. Good. Some people are getting onto this really quickly. Jasmine got it quickly. Zainab got it quickly. Good. So what we did was we took 3 times 8.5. Let's go get my black back. I don't know what happened there. It went yellow again. For some reason, I must have used yellow at some point, and it just changed back all the time. So we got 3 times 8.5. That's a point. Divided all by 2. 3 times 8.5. We use a calculator for that. I don't mind you using a calculator. If you don't need to, that's fine. All right. So 3 times 8.5 was your calculation, 25.5 divided by 2. Just want you to follow along. 25.5. Now we're going to divide that by 2. And if you do that on your calculator, it's going to come out to 12.75. Now, notice that I didn't put any sort of units until I got to my answer, what it equaled. And then I'm going to remember that that's centimeters squared. All right? Always remember that, because that will be wrong on any test that any teacher gives you anytime in the world. If you're doing area, you always have to use your 2 dimensions, okay? And if you're doing volume, then it's 3 dimensions. We'll get to that later. The next one is 6 centimeters along the base and 4.5 centimeters in height. And I can see some really quick answers here. Does someone want to tell me what they did to get those answers? Right. Type in what you think that they did to get those answers. So let me just get a text box. I'll do it right here. Why can't I have it? No, it's not going to give me a text box today. Today's Blackboard doesn't do the things that I want. All right, so there we go. Whole bunch of people. Base times height divided by 2. So it's 6 times 4.5. And 4.5. I'm going to divide that by 2. So 6 times 4.5, without your calculator, is 27. Divided by 2, that equals 13.5. All right? Well, it does if I can never type it. Doesn't want to type 13.5. All right. And again, what I'm going to put there is centimeters squared. Now, the next one's a little bit trickier. And the reason is we have to remember how we've been doing these all along. And I was going to keep doing these because it keeps our brain sharp. What happens when we have 2 things that multiply to give you an answer, but they don't give you both of them? Okay, so we go from multiplication, we go backwards, and we do division. All right? Now, the thing we have to remember here is it's base times height divided by 2 to give us the area. So it's going to be twice as much. All right? If we did 7 times 4, that wouldn't work out. So what we have to do, 28 divided by 4, and then the answer by 2. All right? So we take 28 divided by 4, and we get 14, but we remember that we multiplied that by 2, so we divide it by 2. So it looks like this. What if I could get the thing to work? Okay, 28 divided by 4, by 2, sorry, gives you 14, but we're not done yet because we multiplied by 2, so we have to divide by 2 again, and that equals 7. Now, we could also just do 28, no, divided by 2 would be fine. Okay, so let's just delete that, clear the page. Good. So, then the answer times 2. You're right, it's times 2. I did it backwards because I didn't divide. You're right, Stephen, you caught me. The next one is 100 centimeters. This one you're going to need your calculator for. And our base is 2.5, but we don't know what our height is. So 100 divided by 2.5 is going to give us 40. Sorry, yes it is. And then we're going to multiply that by 2. So we're going to get 2.5 times 80 divided by 2 give us 100. Everybody agree with that? So let's try that on our calculator now that we've got it. That's how you always check if you're right. That's how I knew I was wrong on the last one. I got my calculator and I thought, okay, something's wrong there. So we do 2.5 times 80 divided by 2, and that gives us 100. So then we're right. All right, good stuff. So we'll do some work around figuring out base to height. You'll be able to do that in class next week. Actually, yeah, next week on Monday. So we'll have 3 classes next week, and we won't have FSAs interfering, so that's kind of nice. Remember, by the way, before I give you your homework, that you need to get your test signed and returned. All right. The base of this triangle, I'm going to write it in. I couldn't get it in before. The base of this triangle is 15 centimeters. And the height of this triangle is 8 centimeters. All right? So what is the area? Easy one to do. I'm not worrying about the math. I'm just making sure you know the formula. All right? What is the area? Base times height. And we have to do one more step, which is, put it in there, somebody. Base times height. And then we divide by 2. All right? Only times 2 if we're going backwards, man. Base times height divided by 2. Remember that it's like half of a rectangle. So it's like length times width divided by 2. All right? Once you've got this copied down, then you may go. Look at that. We're done at 4:15. 15 minutes. It's good. Any questions, you guys? Good questions, Dana. It would be good. I don't know if you need a math set yet. We will need them pretty quick because we need to be able to draw circles. But I am concerned that you please bring a ruler to every class now. So I had some people today drawing parallelograms freehand, and that doesn't work very well. Okay, so you do need a math set. In the next couple of classes you'll need it, but right now the big need is for a ruler. Okay, any questions? Thanks, Stephen. Have a good night. Bye. Bye, Jasmine. Bye, Henry. Bye, Lexi.